In this video, we're going to take a look at the Unit 6 review for geometry, and I have it split into a few parts. So we're going to look at the transformation practice first. Number 1 says to describe the transformation resulting from each of the following rules. So describe it precisely. So when we have this adding and subtracting here, this is going to be a translation. So this will be a translation by directed line segment -4, 1. So you just take as if you were plugging 0, 0 in here, and that's going to take it to the point 0 minus 4, so -4, and then 0 plus 1, so 1. So that's going to be a translation by directed line segment -4, 1. This next one where you multiply them, if you're multiplying by the same number, so here we're multiplying by 2's, so both the x and the y are being multiplied by 2. This is a dilation with center 0, 0 and scale factor of 2. Next one has two different things happening here. So this negative in front of the x actually takes and flips your x values. So if we think about where your x values are, and it makes them opposite. So if we had a positive 3x value, now it's going to be at -3. So that's going to flip this or reflect this over the y-axis. So this will be a reflection over the y-axis, and again, that's because of that negative in front of the x, and a translation by directed segment 0, 6. So then we're also moving up 6 units with this +6 on the y. Part D has a translation by directed segment -2, 0. And it also has a reflection. We see that this y is negative, so and a reflection this time over the x-axis, since the y coordinate is negative. So again, this has the similar idea to this, where now our y coordinates are opposite. So now if we had this y value here of like 2, now it's going to be down at -2. So this is flipping. So this negative is flipping over the x-axis. And then the last one. So this last one does some interesting stuff where now the x and y are in opposite spots. So it flipped the x and y, or it switched the x and y, and it's doing the opposite of the y. So I often don't remember this rule, like I don't have it memorized. So I just take a point, like the point 3, 1, and I apply the rule to see what's happening. So now if I put 3, 1 in here, now what I would get back is the opposite of the y. So remember, I put 3, 1. So the opposite of the y is -1. And then I would have the x coordinate next. So my new point would be the point -1, 3. And so then here's this point. So this one is actually a rotation 90 degrees counterclockwise. So I usually don't remember those rules, and I just make up an example for myself and do it to see where it moved to. But you know that it's going to be a rotation when these x and y's switch places. So when they're not in the same spot anymore. So there's another one that would be like y opposite x. or opposite y, opposite x. So you can get a couple different ones, and that means that it's going to be some type of rotation. Number 2, given triangle ABC on the graph pictured, draw the image of the triangle under this transformation. Label the result as T. So we want to go to the left 4. So we want to move in the x direction 4. And then we want to go plus 1. So up 1. So we want to move all these points 1, 2, 3, 4 to the left and up 1. So there's our new B prime. 1, 2, 3, 4 to the left and up 1. There's A prime. 1, 2, 3, 4 to the left and up 1. So there's C prime. And then they want us to label this as T. And then describe that transformation precisely. So again, this is a translation by directed line segment -4, 1. Or you could say left 4, up 1. Then draw the image under this rotation. XY maps to Y opposite X. And for this one, again, I would look at the actual ordered pairs. So I would write them out. So A is 1, 1. B is the 0.2, -1. And C is the 0.30. So now I would do that transformation, which says put the Y coordinate first. Okay, so take this Y coordinate and put it first. So now you're going to have 3 different points, one starting at 1, one starting at -1, and one starting at 0. And then it says take the opposite of the X. So now this X is 1, the opposite of 1 is -1. This X is 2, the opposite of that is -2. This X is 3, the opposite of that is -3. And then you'll plot these new points. So we'll go to 1, -1, -1, -2, and then 0, -3. And then we can connect those. And they want us to label this one as R. Then the last one is doing a dilation. And so this one is having us multiply the X and Y each by 2. So I'll just take these original coordinates that I wrote out right here again, and now we'll just double them. So 2, 2, 4, -2, and then 6, 0. So we're just taking and multiplying all of those. And then plot the points. So 2, 2, 4, -2, and then 0, 6. Connect those. And label that one as S. Number 3, for each rule, describe whether the transformation is a rigid motion, a dilation, or neither. So rigid motions have just pluses or minuses in them, and no multiplication. Dilations have multiplication by the same number. And then neither would have multiplication by a different number. So this first one is going to be neither, because it's got multiplication and addition. So neither. This next one is a dilation because it's got by a scale factor of 2. So these are the same multiplication here. This next one is rigid. It's a combination of a translation and a reflection. D is just a translation, so this one is rigid. E is a translation as well, so this one is rigid. And then F is just a reflection, so that one is rigid as well. All right, now we're going to look at the circle portion of the review. So what is the general equation used to write an equation of a circle with a given center? And so I'm just going to write out a center here. So center being HK, and then a radius R. So the general equation here is going to be x minus our x coordinate squared of our center plus y minus the y coordinate squared of our center equals our radius squared. So it's going to be x minus h squared plus y minus k squared equals our radius squared. So then what is the center and radius of this equation right here? So this number that's subtracted from x here is our x coordinate of our center. And the number subtracted from y here is our center. So remember, if this is positive, we subtracted a -7. So this is actually -7 for your y coordinate. So this would be your center. It's always opposite of what it looks. And then we need to know what number here was squared. So 36 is 6 squared, so the radius is 6. Number 3, write the equation of the circle. So let me get this written out. So x minus our x coordinate squared plus y minus the y coordinate squared equals the radius squared. So remember that we'll take this x coordinate of the center, has to be of the center, and plug it in here. So x minus -3 squared, and then y minus the 2. So y minus the 2 squared, and then equals our radius, which is 5 squared. And then you can leave it just like that. You can also actually square the radius. So we can put x plus 3 squared plus y minus 2 squared equals 25 if you wanted. But either of those is fine. All right, number 4, write each expression as a square of a binomial. So we want to figure out what number multiplied by itself gives us 36 and then adds to that -12. And so the square root of 36 is 6. And then we need it to be negative so that it gets us this -12. And so let me just do that off to the side here for this first one just to show you. So x times x is x squared. X times -6 is -6x. Then -6 times x is -6x. And -6 times -6 is +36. So we're looking for this number, this -6 adds us to our -12, and it multiplies to that 36. So for this one, we're going to have y, and then the square root of 16 is 4, and then we need them both to be positive to get us +8 in the middle. And then square root of 64 is 8. So 8 times 8 gives us 64, and then we need -8 plus -8 to get us that -16 in the middle. So now we just want to fill in the blank with what number would go here to give us a perfect square. So remember, we needed 2 of these to get here. Okay, so we had 2 -2's. And then remember, we have to square it. So then this would be -2 times -2, which is 4. So you're taking that middle number and dividing it by 2. Okay, that's getting us to this -1, and then squaring it gets us to +1. So -18 divided by 2 tells us that that number is -9, and then we square it to get that end number. So remember that that had been x minus 6 on that last one. So that gave us 2 -6x's. And then the -6 times -6 gave us that plus 36 at the end. So it's this middle number divided by 2, and then we square it. Number 6, find the center and radius of the circle with this given equation. So for this, we need to use what we just did. So you'll see this part, okay, from the last one in part A. And so we want to put in that, and actually let me draw this in black first. So we want to come up with the number that we would add in here that would make this a perfect square binomial. Okay, so what number are we going to add right here? And then same for the y part. What number did we add to make that a perfect square binomial? And then we're going to have to do that to both sides to keep our equation balanced. And so again, you just did this on the last problem. But the number that went here was -4 divided by 2, which is -2 squared, which is 4. Now, when you add it to this side, you have to add it to this side as well. Then same for the y. So -2 divided by 2 was -1, squared was +1. Add to both sides. So now you're going to factor this, okay, and do it like we did here where we're making them perfect square binomials. So this one is going to be x minus 2 squared. And then this one is going to be y minus 1 squared, because -1 times -1 is 1. And then 20 plus 4 plus 1 is 25. So then that helps you get the center and the radius. So the center here is 2 for the x. Remember, opposite of what it looks like. And then 1 for the y. And then our radius is the number that squared gives us 25. So the radius is 5. Then we want to graph the circle. So we'll plot this point 2, 1. Okay, so 2, 1 is right here. And then you would count using the radius. So I would go up 5, down 5, to the right 5, and to the left 5. And then just draw the best circle that you can. If you have a compass, you could certainly use that. Otherwise, just draw the best circle that you can. I'm going to use my compass drawer. So then there's the circle. Now for part B, it says for each point, determine if it's on the circle. And you can just look here for some of them, like 4, 0 is obviously not on the circle. So if we go to the point 4, 0, it's obviously not on the circle. And the way that you check it is by plugging it into this equation. So we would do x, let me write this out. So we would be plugging these values in. So instead of x, we're going to be plugging in the x value. So x minus 2 squared plus y minus 1 squared. And then that should equal 25. So this is what we're going to do is plug these all in here. So for this point, our x is 4 and our y is 0. So then 4 minus 2, this is 2, squared gives us 4. 0 minus 1 is -1, squared is 1. 4 plus 1 is 5, which does not equal 25, so this is not on the circle. And then we'll just keep doing that with these other ones. So we'll be doing -3 minus 2 squared plus 3 minus 1 squared and see if that equals 25. So I just plugged these points, -3, 3 into our equation. And so -3 minus 2 is -5. And then we're going to square that. And 3 minus 1 is 2 squared. So -5 squared is 25. And 2 squared is 4. That's 29. So this one is not on our circle. And then the last one, -2 minus 2 squared. And then negative 2 minus 1 squared should equal 25 if it's on our circle. Again, we just plugged in this negative 2 into our equation. So negative 2 minus 2 is negative 4. Squared is 16. Negative 2 minus 1 is negative 3 squared, which is 9. 16 plus 9 equals 25, which is good. So this one is on our circle.